Hotkeys are an efficient way to select commands on a keyboard. For instance, they are fast, particularly for repetitive commands, such as multiple copy and paste operations. They reduce hand switching between the keyboard and the mouse for text-driven applications. Unlike menus or palettes, hotkeys do not consume valuable screen real estate. Despite these advantages, hotkeys can be difficult to guess due to name collisions and non-intuitive mappings. Hotkeys also lack expressiveness. Since each key only communicates one bit of information, shortcuts frequently require multiple keys. If a hotkey is difficult to locate, users may be forced to remove their eyes from the screen. Or, a user can make an error and select the wrong key. We propose the Métamorphe keyboard, a novel keyboard with height-changing keys designed to improve hotkey usage. The Métamorphe keyboard has a similar form factor, layout, and tactile quality as a traditional keyboard. It increases haptic feedback by modifying the shape of the surface. It increases expressiveness by allowing new forms of interaction with the keys. Finally, it does not impact text input. Keys are only raised when the user presses the Control key to select a hotkey. The Métamorphe keyboard has several advantages. Users can use haptic feedback to locate hotkeys and select them without removing their eyes from the screen. Haptic feedback can also be useful to locate lowered keys that are next to a raised key. Raising keys offers a new design space for hotkeys. Users can not only push the tops of the keys, as they do today, they can also push the sides of the keys, or squeeze them. This increases the total number of available hotkeys and can improve their guessability. We ran a user-defined hotkey study, which shows users the result of a command and asks them to provide the key and finger gesture they feel would be the most intuitive way to activate it. Participants made significant use of our new gestures and revealed a wide variety of mental models, including many that were shared by multiple participants. Our prototype for the Métamorphe keyboard uses a regular USB keyboard equipped with custom-built keys containing sensors and actuators and a customized frame. We used push-type solenoids to move a key up and down and placed a force sensor on each side of the key to detect gestures. These are all controlled using an Arduino microcontroller. The solenoids are small enough to be integrated into the keys. A pilot study determined that an elevation of around 4 mm allows sufficient haptic perception without impacting the ability to easily reach the top of the key. We designed and 3D printed our own frame to embed our customized keys. We ran a user study to investigate the ability of users to select hotkeys eyes-free, as well as the impact of raised keys on speed and accuracy. From this study, we learned that hotkey selection is faster on the Métamorphe keyboard than on traditional keyboards, and that raised keys do make effective haptic landmarks for nearby lowered keys. In conclusion, the primary contributions of this paper are the design and implementation of the Métamorphe keyboard, a keyboard with height-changing pushable keys, an analysis of the design space of raised keys for both input and output, 2 user studies that validated the usefulness of the keyboard for selection of hotkeys and provided a set of user-defined hotkeys